for you, Keith, I would love to know when you talk about being able to develop transparent models, what does that mean? I mean, so like, one obvious thing to me is I'm like, okay, well, we could limit ourselves to regression models where we can see the beta weights and we can say, uh, this independent variable is contributing exactly this much to the result because we know exactly what the beta weight is and it doesn't interact with the other input variables. Um, so that's like one way of doing it, but then we're pretty limited in the approaches we can have. So you mentioned Lime there. So Lime is a tool alongside SHAP. They're probably the two most popular tools for doing explainable AI. Is that enough? Is using these kinds of tools post hoc after the model's been developed to have some sense of how inputs relate to outputs, even if we can't get down to an individual weight level? Yeah. What do we need? I guess in the healthcare
It's
space
a
specifically, what do you need to show to be able to say we're transparent? And yeah, what are you happy with at Pandata in any industry?
well, it's a tricky issue, and I'm gonna what I'm gonna speculate about here isn't so much a Pandata answer as much as what I've come up with myself, exploring the same kinds of things that I'm sure that Serge was talking about in that episode, because I prepared an XAI course. In fact, I'm losing track of my calendar here, but I think I'm giving a half-day XAI workshop in less than 2 weeks, or just about 2 weeks, or something like that. I'm speaking at TDWI in Las Vegas in February. Um, so the way that I usually describe it to folks is that first scenario that you were saying, where you have something that's inherently interpretable, is what some folks, I like to use this phrase, call interpretable machine learning.
Right.
So for me,
The regression
IML,
model. The regression model to you is interpretable machine learning. Yeah.
yeah, I would agree. And then I would include in that, for instance, a single decision tree. So I
Right.
think
Right.
part of it is not being shy about using these simpler techniques in two senses. One is, I think you should always, always use a simpler technique when you're prototyping. It drives me crazy when a modeler will go right to a complex technique, maybe because they did a tournament of algorithms in auto ML or something like that. They probably had some kind of justification for doing it, but they'll go right to the more complicated technique. And then if I ask them, how much additional accuracy did you gain by going more complicated? I I don't get an answer. That frustrates me. I just think that's bad practice. So
Yep.
I treat the IML solution as a pace car, so to speak, right? And then I go to see, if I go more complicated, what's the gain? One of the reasons I think this is important, even for analytics leadership, so somebody like an analytics director or something like that, and they may have gotten that role because they get promoted out of BI or IT, so they might possibly be managing data scientists, but not be a data scientist themselves. This kind of thing happens all the time.
Mhm.
I always coach them to do that, because that additional gain in accuracy, it's not just that you're going to lose transparency, but you're probably going to be forced to do XAI on top of it. So you've just lengthened the project. So there's actual, dollars involved now, where the project has just become more expensive. So,
Mhm.
so I reserve explainable AI not for the interpretable piece, but when you have to add that explainability layer on top of a complex model.
Yeah, yeah, yeah. And to your point of expense, those more complex models are probably going to cost more to train, and they're going to cost more to run at inference time as well. Other reasons why we might want to have a simpler model, like a regression model or a decision tree.
And
If you get a negligible, there might be, in terms of winning a Kaggle competition or whatever, there might be this 0.1% improvement in accuracy or AUC. And okay, cool, that wins you the tournament. But in practice, that doesn't change the human's experience of using this model. Nobody's going to notice
W-
that difference, but they will notice if it takes several seconds for the model to output something to the screen as a, somebody in a production web interface or something, your end user of this model, if they have to wait, you could have been using a simpler model that was tiny little bit less accurate, negligibly less accurate, but gives you results instantly, and it is cheaper to run.
Yeah, well said. First, thank you for making the distinction between training time and scoring time, because I find that folks forget about that. Because maybe you can tolerate a longish training time if it's going to be done infrequently,
Mm-hmm.
but that scoring time might be critical.
Mm-hmm.
And what you're going to wait until you get to the ML ops phase, and you're going to have your machine learning engineers or whoever's in charge of scalability issue. You're going to dump that problem on them. You have to be thoughtful about that early on. I remember being on a gig. It happened to be an IBM gig, and scalability was an issue. And I don't remember the details, but it was something like, Keith, your model's taking like 7 or 8, milliseconds per record at score time. We'd love to get it down to 4. How
Mm-hmm.
much accuracy will we lose if we go from 40 variables to 30 or 40 variables to 25 and so on? So in other words, I was having a constant dialogue with the person who was going to put my model into production.
Mm-hmm.
Um, uh, but what was the other thing that I was going to say about that? So about score time, but then also, oh yeah, the trade-off. So what I think is so important for us to remember on the technical side, on the data science side, although people are technical in different ways. Like I don't think of myself as being very savvy on the data engineering side, for instance. There's all kinds of different technical, but for those of us that are technical on the data science side, I don't think it's our decision whether or not we go for that extra 1/10 of a point of accuracy. I think it's a business decision. I mean, I really do. I hope that most people agree with me, but I think what happens is the fear is that the senior leadership or even analytics leadership won't fully understand all the details. Everybody's always talking about how they don't trust their boss to go into the weeds with them. But that is really something that they have to decide. We don't get to decide that. So as an external resource, or as a consultant, at Pandata, that's a client decision. And that's a different kind of transparency. That's not necessarily model transparency, but it's a kind of process transparency that we would take very seriously too on a consult. Um, there are some consultants that just want to take the data, kind of disappear, and then come back with the model.
Mm-hmm.
And if that's the case, they're not giving the client the opportunity to decide between the more expensive model that's 1/10 of a percent more accurate.
Yep. Yep. It's we've had a lot of guests on the show talk about this problem of data scientists being too siloed and not kind of working with the business iteratively to see what's best. So thank you for highlighting that. There's an interesting kind of nomenclature point of difference between you and Serge. So XAI, this explainable AI area, is in its infancy in a lot of ways. There aren't a huge number of tools or a huge number of books out there today. I know that there will be in 5 years and even more in 10 years. And it's interesting to hear. So you define interpretable machine learning as um, as models like a regression model or a single decision tree where it's very straightforwardly interpretable. Um, and it's interesting. So Serge's book is called Interpretable Machine Learning, and it's all about XAI techniques like using Lime and SHAP. So it's interesting. So as the field develops, we'll probably start to have more standardized ways of describing these things. I totally get the way both of you are doing it, even though it's different. Both ways make sense to me.
Yeah, and I'm glad you raised that issue because I'm when I give talks on the subject, I try to be cautious about that. I adopted the language that I did. I was influenced by two sources. The Association of Computing Machinery did a cover story on this, and I said, well, if I try to use the terms the way the ACM is doing it, then why not? I'm going to kind of stick with that, right? But
Mhm.
there really isn't a consensus. And somebody else that's been a real influence, by the way, is Cynthia Rudin, who's at Duke. I've never met her, but I'm a huge fan. And she thinks that, generally speaking, XAI is a mistake in
Hmm.
that it's never more than an approximation of the black box model anyway.
Right.
Now it might
Right.
be a darn good approximation, but
Right.
approximation nonetheless, right? So
Yeah.
she thinks that it's not really truthful to say this XAI is your model. You got to be clear to the client, to the
Right.
decision maker,
Right.
that it's not. Also, she thinks that we exaggerate this notion that you have to be more complex to be accurate. So she's tried to develop algorithms where there's a very, very thorough search of the problem space, but it results in one tree, not an ensemble.
Right.
And the reason we do random forest and other things is that trees are greedy, so they tend to optimize locally, and we don't get a good overall optimization. So she says, well, that's true. You don't have to do CART like it's 1984. Go ahead and leverage your GPU, leverage your fast contemporary computers, but try to have one tree pop out at the other end, not 1,000.
Right.
Uh, I'm not an expert certainly on her approach, but she's been a real big influence. So whenever I present XAI, I don't take as strong as a position as she does. I think we have to have this skill set. We have to do this, but it's this constant kind of cautionary reminder that maybe there are times that we go complicated when we don't have to.
For sure. As we often discuss on air with guests, deep learning is the specific technique behind nearly all of the latest AI and machine learning capabilities. If you've been eager to learn exactly how deep learning works, my book, Deep Learning Illustrated, is the perfect place to start. Physical copies of Deep Learning Illustrated are available in 7 languages, but you can also access it digitally via the O'Reilly Learning Platform. Within O'Reilly, you'll find not only my book, but also more than 18 hours of corresponding video tutorials if video's your preferred mode of learning. If you don't already have access to O'Reilly via your employer or school, you can use our code SDSPOD23 to get a free 30-day trial. That's SDSPOD23. We've got a link in the show notes. Now, what you're saying there about not having to go complicated makes perfect sense to me, particularly when we're working with structured data. I can believe that there's a simpler model, but yeah, you're nodding your head. So I think you kind of
Yeah,
get where I'm
for
going with
sure.
this. When there's situations like raw images or raw video or natural language, then it gets trickier. And it seems like, having like the deep learning models that are very difficult to explain, they are able to handle all of the nuance and the pattern recognition in those big unstructured media files.
Yeah, and you came up with exactly the same list that I would: video, image, audio, natural language processing, even if it's text, but trying to do that, finish the sentence, or
Mhm,
text to
mhm.
image, and all this kind of stuff. Um, that's where not only where deep learning shines, but where 5 or 10 years ago we had made so little progress.
Right. Yeah.
But I'm a skeptic when it comes to deep learning on structured data.
Mhm.
Maybe it's because it hasn't happened yet, or I haven't been convinced yet. I'm not sure, but I haven't seen anything that convinces me yet that I should
Yeah.
be doing lone default with deep learning.
Yeah. And myself personally, as well as dozens of deep learning students that I've had over the years. So I have taught deep learning courses online or in person for many years now. And you get these people that come from finance and are like, I'm going to build the best stock prediction model ever, using structured data, or like you're saying, like loan default prediction, or any of these kinds of things where you just have discrete independent variables as opposed to unstructured media files as inputs. And yeah, they don't outperform the, best practiced kind of linear regression model. um, so yeah, anyway, I just wanted to kind of highlight the difference. So have we answered the question? We've gone down on a long tangent here, but my initial question was, what does transparency mean anyway?
Well,
So we know now that, of course, yeah, you and I are on the same page. If we have what you call an interpretable model, like a regression model or a single decision tree, obviously that's transparent. But then are there situations that you run into a Pandata where you are working with unstructured data and deep learning models and you need to be applying XAI, and there's a point that you get to where you're like, okay, it is transparent? Or is that just that's not really in scope for the kinds of work you guys do?
no. I think, again, for instance, medical imaging is something
Right.
that Pandata's done work in. Now, so
Right.
the XAI is on the table again, and that's where, although I'm a huge fan, I'm not prepared to go as far as Cynthia Rudin because I'm just not sure how you do that, right? I'm not sure how you always restrict yourself to
Yeah.
inherently interpretable if you're
Yeah.
dealing with something like medical images. But I
Yeah.
think, as we've been talking about it, and I bet my colleagues at Pandata would agree with this, that such an important part of transparency is not just the transparency into the math. It's the transparency into the process so that the client can be a full, educated partner in the development of the solution. What I always remind folks of is that the way that you judge, a model isn't that it's better than some set of business rules that existed before the model or something like that. I mean, this gets into our 5 Minute Friday topic, really, where what you're doing is you're entering this new world. There's the new world that has the model in it. So a proper model evaluation has to compare the entire human computer collaboration that existed before the model was built and after the model was built. The humans are still part of the equation. So transparency, I think, is transparency into the process
Right.
so that the client really understands this because they have to embrace it.